Okay, welcome everyone officially to the last lecture and workshop of the semester. So this is kind of the culmination of our Python, although I've talked to some of you already, and like I said, we'll still be talking about Python quite a bit next semester, but hopefully if everything gets installed in a timely fashion, which there's no guarantee, but if IS actually gets Matlab on these computers over the break, like we hope they will, we'll be starting up next time doing Matlab. So, we'll finish up Python today and talk a little bit about what we'll do next semester. But, basically what we're doing, at least the first few weeks of next semester, is talking about Matlab and learning to do the things in Matlab that we've already done in Python. So hopefully now that you know a little bit about programming in general, learning a new language will happen much faster than learning Python did when you didn't know any programming. So we'll hopefully move a little bit quicker through Matlab and then get to spend some time learning more sophisticated things and so forth. But one of the major things we'll focus on next semester is not just Matlab itself, but comparing and contrasting Matlab versus Python and sort of the strengths and disadvantages associated with each one. So over the break, I'm going to have to come up with some new comics to put up here because this is the last XKCD I had on my list for this class. But this is one that's debatably true. I would argue that this effect happens in academia a lot too. You guys might even feel this way on some of your problem sets that you accomplish what feels like some brilliant novel thing and you don't get any actual credit for it. So I'm not sure that this is always the case, that when you solve some really difficult problem, someone's like, oh, we could publish this. What often happens, or at least some friends of mine and I have found this is the case, is that you come up with some new way of analyzing your data or something like that, and you just think, well, that's a good way to analyze my data. And then a year later, you see that somebody has published this as a big, fancy methods paper, whereas you just thought it was kind of the logical thing to do. So sometimes you get credit and sometimes you don't. And there are stories in the literature of there's one. Have you guys heard the story of a guy named George Dantzig? Anybody heard of this guy? He was a graduate student. This was in the 40s or the 50s, I think, in the United States, or maybe the 60s. And he came in late to a class and saw some problems on the board, and he thought they were homework. And they were actually, this is like an urban myth, but this actually happened. They were actually examples of unsolved or unproven statistical problems. So he comes in a few days later and lays the problems down on the professor's desk and says, I found the homework to be kind of difficult this week. And the professor's like, wait, you solved these? We can publish this. This can be your PhD thesis. And that was kind of interesting. So I haven't given you, I'll tell you now, I haven't given you any unsolvable or theoretically unprovable problems on your problem sets. But, maybe you'll come up with some novel solutions once you practiced a bit more that might be publishable someday. All right, so let's just review where we are. So again, we're finishing up reading and writing files today and just talking about some general stuff. We're going to not worry about these last couple of things I was thinking about covering, but we might bring them in once we've covered Matlab for a bit. So last time we talked about writing files. We're going to review that a little bit and then talk about reading files and then just sort of talk about wrapping things up for this semester. So in terms of just administrative stuff, so you guys should have all gotten your feedback and your marks back for problem set 4. Is that right? So, despite everyone's complaining about it, people actually did overall pretty well here. I mean, a lot of people, this was not your best problem set. But a couple of people actually either tied or got their best score on a problem set, on problem set 4 so far. So actually, the range of scores was not as bad as I feared from how much people were panicking about that one. So I think everyone's still doing fine. Everyone's still in a really high grade range right now. So that means I'm going to have to keep making these problem sets and the exam really hard in order to get a nice range established. So anyway, so everyone's doing very well so far. Hopefully you're finding problem set 5 easier than problem set 4. I mean, there's some problems on there that are of comparable difficulty, but if you manage to get through problem set 4, hopefully problem set 5 will not add much difficulty. So that's due today at 1 minute before midnight. In theory, if I get all of problem set 5 turned in on time, I will then be able to release the key to problem set 5 as well as problem set 6, either at midnight or first thing in the morning tomorrow. Problem set 6 requires me giving you the answer to some of the problems in problem set 5, so I will hopefully everyone will turn their stuff in on time so it doesn't delay me getting out problem set 6 and the key to problem set 5. So that'll be due on the 14th of December, which is next Friday. Hopefully you guys won't find it too bad. I pretty much have it finished. And I think it's a relatively enjoyable problem set, hopefully. We'll see. Then your project proposals will be due a few days later on the 18th. I think most people have already come and talked to me about them, but we can talk about them more if you need to. As I emailed you, there's a sample project proposal on Google Drive that is going to be my little homework for myself over the break to see if I can do my own little project in Python just to commiserate with you guys. And again, like I said in the email, this is a project that is as ambitious for me as I expect your projects to be for you. So my project would be a little overwhelming for you guys, but that's because I already know this stuff. So I'm challenging myself the way that I expect you guys to challenge yourselves, but the challenge level for your projects will be should be significantly lower than my project for myself. But that project proposal tells you, shows you the kind of things I'm looking for you to do, to talk about what thing, to show that you have a good roadmap for your project, a good plan, a good outline for how the whatever you're writing, whatever program you're writing is going to work. That you've thought about some of the ways you're going to do things, some of the algorithms you're going to have to implement, some of the problems you might face, or some of the things you're going to have to teach yourself, that kind of thing. In terms of how to turn these in, so this is the last lecture, so I'll just tell you now. For turning in the project proposals, you can just send it to the Gmail address that you've been sending the previous problem sets. I'm not going to be as picky about the format as I am with the problem sets, because this is a little bit kind of a different thing. Just, like the problem sets, don't put your name in the actual file. Just put your student ID on the file, but you don't have to use a particular name. Just say project proposal or something like that and your student ID. I don't need to see an exact format for that. So yeah, so that's the main thing. And send it to my Gmail. It'll be due at, I guess, midnight on the 18th of December. I'll say midnight on the 18th of December from any time zone on Earth, because I can't work out the time zone arithmetic because I'll be in the United States by now. So I think you guys are 13 hours ahead of where I'm going to be. So some conferences have this so that they don't have to clarify. They'll say that, like, the abstract deadline for registering for the conference is midnight from the latest time zone on Earth. So we'll say it's that. It's 11:59 p.m. On the last time zone on Earth, which is, I guess, 1 hour east of the international date line. So hopefully before you go to bed on Tuesday, December 18th, turn it in. Okay. If you haven't done the podcast survey yet, those are still online. I would appreciate people doing those because, A, that'll help me with my post-grad education certificate thing we have to do, and also hopefully will help me improve this class for next semester and next year. But again, it's not mandatory, but I would appreciate it. And I think a couple people have already done it. And if you haven't, there's still time. Okay, any other questions or issues or things people wanted to bring up or talk about, administrative stuff? Everybody good? Okay, so let's just talk a little bit about reading files. This is the last topic we have to talk about. And there will be some reading and writing file stuff on your problem set, so it's good to pay attention for this. And if you remember last week, we wrote out some files. So, we can go over that a little bit at the beginning of this class because I know we did that a little bit quickly. And then we'll talk about writing a script for reading back in these files. So, obviously, reading in files is a very useful thing to be able to do, right? Because maybe, if you're doing a cognitive task, for example, one thing that you often want to do, and that, has come up a lot in my research and people have talked about it for their final year projects and so forth, is, how do I tell my experiment that I want to use a certain stimulus list, for example, right? Well, a common thing you might want it to do is read that stimulus list in from an Excel file or a text file or something like that. Now, Excel files are a little tricky to read because they're a very specific format, but it's pretty easy to actually read in text files. So if you're wanting to design an experiment where you decide what the stimulus orders are for each subject or something like that, and you have a list of stimuli stored in a file, you can pretty easily design your experiment to read those files and display, for example, a different stimulus order for every participant that you figured out ahead of time. And another obvious case where this might be really useful is if you're doing data analysis, right? So we've focused on programming cognitive tasks, but of course data analysis is something that you use computers for all the time. And as we sort of showed last time, you can even build a little bit of analysis right into your task if you want to. But if you want to write a separate script to analyze your data, you're probably going to be wanting to read in data from a file. So like a text file again, or something with a known format. It's not too hard to read in from. Okay, so the actual reading of the data part is not the hard part of this. Basically, the only tricky part is exactly how you process the data once you've read it in. The actual reading of a text file, assuming everything works out well, is really only a couple of lines of code. And then it's how you process the data that could be tricky depending on what you're trying to do. So if you guys remember last time we talked about file objects, right? If you use this open command, which is a command that's built into Python, you can open a file. And if you remember, the way that we opened a file for writing is we use the letter W here to open a file for writing, right? So remember, if you open a file for writing, that obliterates the file. If there's a file there already, it clears it out and replaces it with an empty file, right? But if you use the open command and specify some file name and an R right here, that opens that file up for reading, okay? So that means that's like double-clicking it and opening it up in Notepad or something like that, right? It's opening it for reading. It doesn't change the file or anything like that. In fact, you're not even allowed to change the file if you open it for reading. So this is the version of the open command you want to use if you're reading a file. So you just say open and the name of your file name, and then specify the string that's just the letter R, and that will return a file object that, in this case, I named my file, that you can use to read your file. So just one thing to note is if you're copying and pasting code, super important to remember whether you're reading or writing a file, right? Because if you have a W, if you want to be reading a file, but you actually accidentally paste a line of code that uses a W here, you're going to, instead of reading your file, you're going to replace it with an empty file, right? So super important that you specify that you're reading the file and not writing the file if you intend to read it. Okay, but that's pretty easy. There are a few different functions for reading in the file, but I'm only going to really teach you one because you can do most of what we need to do with this one file reading function. So the function readLines will basically what it'll do is it will read every line of the file. So the whole file, it'll read the whole file and spit it back to you into a variable called sumLines. And what that'll do is it'll actually return you a Python list of each line of the file. So each line meaning what it means for us when we're looking at it, like everything up until you hit the enter key and there's this new line, right? So, if you have something like a text file that's tab separated, like we printed out last time, each line of that file might have a value, then a tab, then a value, then a tab, then a value, then a tab, and then, a new line would start. So everything that's on that one line of code would go into one string in this list of strings, right? So some lines will be a Python list of strings where each string is one line of the file, right? So then so that reads the whole file into this list. So you wouldn't want to do this if you had a file that was like 100 gigabytes big. You wouldn't want to do that because it would take a very long time and take up more memory than your system has to read the entire file into a Python object, right? That would basically crash your system. But most of the files you guys are going to be working with are, maybe a few bytes, a couple of kilobytes, right? Like a stimulus list or output from one run of data or something like that is not going to be very big. So you can afford to just read the whole file at once into memory. And that's usually going to be the easiest thing to do. So there are functions for reading like a few bytes at a time or reading only a certain position in a file, but for right now, let's assume you're going to read the whole file in, and you're going to use this read lines. Okay? All right, so that's what read lines does. And just like when you're writing a file, when you're done with it, just remember to always call the close method of that file object to close the file. That makes it available for other programs to open if you want to. It lets, if the file's on like a flash drive or something like that, it tells Windows that it's okay to eject the flash drive and all that stuff, right? So when you're done reading all the lines of the file, you just call this close method, and that makes the file available again for other programs. Okay, so let's practice this a little bit. We'll review what we did in last week's demo, because that feels like a really long time ago, I think, for most of us. And then we'll write a little script to read in the file we just made. And of course, you would use a similar sort of code to read in a stimulus list. We won't be doing that exactly today, but it would be pretty similar. And just to note that you should probably pay attention to these demos, because you'll be doing something pretty similar in problem set 6. So I would say, you can follow along if you want to, but mainly let's focus on understanding this time. And I will make this code, well, I'm not sure if I'll make today's code available for you, like to download, because it's pretty similar to what you're going to do in the problem set. So maybe you can either follow along now or type it out based on the podcast later, whichever you'd like to do. But it's going to be giving you a little bit too much if I give it to you, I think, directly to download. So let's mainly focus on understanding. And I think you guys won't find this too hard to do a modified version of this on the problem set. Okay, so if you remember last time, we had finished up with this kind of dumb little psychophysics demo for now. What was that called? That was in the shoes folder. So we had Psychophysics Demo 3. And if you remember, what we did here is we had this silly little contrasts of shoe pictures task. It's not quite a real psychophysics task yet, but it's sort of getting there. But the key thing we did here at the end was write out a file, right? So if you remember, what we had done in the course of this task is we had been making a list of response times, right? So we had a list of response times, which is a list of integers that we created, right? Which had each response time in milliseconds for each trial. And we also had a list of accuracies, again, one entry for each trial, where it's either a 1 if the person got it correct, or a 0 if the person gets it wrong, right? So we created this code here, which creates an output file. And again, if you remember how we did this, we said we have a subject label that's probably going to be a subject number, or maybe, if you're not so concerned about anonymity, like their initials, or just some string that identifies the person, right? And we got that back up here at the beginning of the task when we displayed this dialog, right? So again, if you remember, we introduced some new stuff in the course of making this dialog that we're not really going to talk about too much, but this is a chunk of code that you could copy and paste and reuse pretty easily in your own experiments. So hopefully, even if you don't understand some of the subtle details here, you kind of get what's going on. We're creating a new dialog box. We had a field that people can enter text into called participant number label, shows the dialog box, and then that makes it wait till the person clicks OK. If they click OK, then we say that the sublabel is whatever they put into the dialog box, and if they cancel, we quit, right? So if I want to run this again just to show you that dialog box, that's what this code does, right? So it creates a new dialog box called participant info, right? Here, participant info is what goes in the heading of the window. Then we add a field that says participant number / label with a question mark, right? So that adds a text field. I can enter 1, 2, 3, or I can enter my initials, MJ, or whatever I want to in this field, right? And then if I click OK, whatever I put in that text field is going to go into the variable sublabel as a string, right? So for right now, what I'm going to do, because I don't want to run the whole task again, is just click cancel. And we actually have a condition to handle that too, right, which is just to quit the task early without running the rest of the code. Okay, so we have this subject label. So we use it. We use the prefix sub plus the sub label plus underscore data.text, right? So we build a string that's going to be sub 123 data.text or something like that. This is just to sort of print a little message to the output saying that we're creating the output file. That's not too big of a deal. And then we open the file name for writing, right, with a W. And you remember the way that you write data to a file is you just say, take your file object and say file object, in this case called output file.write, and then some string that you want to write to the file. In this case, it's trial number. Remember that \t is a tab. So trial number tab, accuracy tab, RT, new line. And then we do a for loop through all the trials of the task, right? So n trials is how many trials we have. So for every trial in the task, we construct this string that's what we want to print out, which is placeholder tab, placeholder, new line. And those placeholders are going to be replaced by the file number, or sorry, the trial number. And we add 1 to that just so it goes from 1 to 50 or whatever instead of 0 to 49 or however many trials we have. Then the accuracy for that trial number, right? So we access the item in the accuracy list that's appropriate for this trial, and then we access the item in the RT list that's appropriate for this trial, and write that out. This is some little thing that we added at the end, is we also wrote a little code to calculate the average response time and accuracy by summing up all the RTs and dividing by how many reaction times there are, and summing up all the accuracies and dividing by how many accuracies there are. So we also printed at the end of the file the average accuracy in RT, and then we close the file, right? And remember that generated an output file that looks something. Let's do this by kind. Where's my text file? Oh, it's in the shoes thing. Okay, so this is the last one we created, so subject 999. If we open that up on our favorite text editor. All right, so we had 5 trials here. So you get this trial number heading with a tab. You can see that's a tab there. The accuracy, another tab, RT, new line, 1 tab, 0 tab, 995, right? So you've got trial number, accuracy, 1 or 0, and RT, and the average accuracy printed out. I'm not sure why we didn't get average RT in that one. Maybe we didn't run the last version where we wrote out the average RT. I don't remember. Okay, so that kind of makes sense to everybody. Everybody remember how we wrote out this file, all that good stuff. So hopefully that makes sense to you guys. Okay, so now we're going to start a new demo, which is reading in a file. Okay, so we're going to start a new file. Just going to grab my notes here on doing that. Okay. So to make it simple, let's just tell it the file name. So let's say we're going to use that. Let's see what we got in these different files. So actually, let's use, for this example, because when I originally planned these examples, I wasn't going to put the average accuracy. Oh, here's the average RT. I wasn't going to put the average accuracy and RT in the file. I was just going to have something like this. So let's use subject 007 as our file name that we're going to process just for an example. So I'm just going to make a variable called file name, and I'm just actually going to copy from the OS. So I'm just going to say this is the file I want to open, right? Now again, in real life, if you're writing a script, you might give a dialog box so somebody can select the file to process, or you might have some system, right, where you tell it to loop through the first 20 subjects or something like that. But right now, we're just going to be a little bit lazy and just give it a file name. So again, the steps for creating a file object and reading in the file are pretty easy. So, whoops. So you can just say something like my file or whatever you want to call file object equals open the file name, right? So that would be sub007 data.text. And remember, very important that you specify R there and not W, because that tells Python you're only going to read. It's not going to let you write any information to that file. Okay. Now, if you want to read all the lines of the file into Python list, you just say something like all lines equals my file dot read lines. Okay, again, so that's the read lines method of the file object, and that reads the entire file one line at a time into this list, and then my file dot close. I'm going to save that as, what did I call this? Let's call this PsychoPhys Demo 3 file reader, something like that. Okay, so in terms of when we say that we're going to learn to read files, we just read the file. Those 3 lines did all we need to do. That's not, like I said, that's not the hard part. The hard part is now doing something with this information that makes sense, right? So figuring out how to parse this data or process these lines of data into some sort of useful format. So for that, we're going to learn a couple new tricks. But if we just wanted to do this right now, we could even say, like I could do this in the Python shell right now. So I could say like my file equals, or let's call it something a little bit different. Just call it ABC for a quick demo, equals open sub 007 data.text. Open that for reading, right? And say ABC, oops, def is a thing. Let's call it ZZZ equals ABC.readlines. I'm just using different variable names to clue you in. This is just kind of a temporary testing out that we're doing. And then ABC.close, right? So I've just done the same thing here. And if I look at what's in ZZZ, or ZZZ, I guess, if we're using British English. So this is what I get, right? So like I promised you, we get a Python list, right? So it's got the first item in the list. It's got trial number, then a tab, accuracy, then a tab, then RT, then a new line. And you notice that what it did here actually is it's showing you, it's showing you the actual \t. Now that does not mean that the literal file has a \t in it, right, in text. It's just saying that that's how it's representing a tab. So it's representing a tab to you the same way that you tell Python you have a tab. So trial number tab, accuracy tab, RT, new line, 1 tab, 0 tab, 1573, new line, right, which should be, that's the second line of the file, and so on, right? So now we've got this list, and we can see it's in kind of a regular format, and we have to figure out what to do with this list, right? To maybe average things or process them in some way or just spit them out again, right? Now, if you wanted to do just something silly, we already just kind of did this, but just for illustrative purpose, if you just wanted to print out all the data to the output so that somebody could see what data is in the file for some reason, you could say something like, all right, number of lines is equal to the length of the all lines variable, right? Whoops, not lions, lines, right? Remember that len we used to see how many items are in that list? So in this case, 1, 2, 3, 4, 5, 6. We should have 6 items in the list, right? And then we could say, make a little for loop, counting through each line. So if we go through each line in x range n lines and call that loop variable line num, we could say something like current line equals all lines bracket line num. Right. Hopefully this kind of phrasing or syntax is getting sort of more familiar to you guys. So basically we're looping through each of the lines, setting current line equal to whichever line number we're currently on. And we could say something like print line placeholder, another placeholder, use that .format thing of the string object, and our first placeholder will be whatever line we're currently on, line num, And again, if we want to make this human readable, we add 1, right? Because humans usually count from 1, not from 0. And then current line, right? So this is just a dumb little function, or not even a function really, but a dumb little script to just read the file in and spit it out to the output here, right? Again, ignore all these error messages. That's just a PsychoPy bug of some sort that doesn't matter for us. But if we run this, this is what we get, right? So line 1 is indeed trial number tab, accuracy. Should be a tab in there, but for some reason it's very small. RT, for some reason, oh, I know why it's doing that. So Python's actually printing an extra line in here. And the reason that is because if you look back at this list, it reads in these lines, and it still includes that new line character at the end, right? And usually when you use the print command, it automatically inserts a new line at the end. So what we're effectively doing is inserting 2 new lines at the end of each when we print this, right? Because there's the one new line that comes from the print command and the 1 new line that's actually in the string, so that it effectively double spaces our output here. But you see that this just prints out the output, right? So line 1 is indeed trial number accuracy RT. Line 2 is indeed 10 and wait a minute, what's going on? Oh, sorry. You know what that is? That's, again, it's because the tab output is not very friendly here, but what this is actually 1 tab 0 tab 1573, right? Because that's what's in our file is 1 tab 0 tab 1573. The output window just isn't formatting that very nicely for us. For some reason, this tab window periodically forgets the font settings. You see how the font changes. So actually, if I quit PsychoPy, start it up again. This is another weird, like, just graphical bug of the PsychoPy software that has nothing to do with our code. If we run it again, it should look a little nicer. Okay, so that looks a little bit better, right? There, the tabs actually show up as tabs. And it's back in that nice mono-spaced code font. Okay, so here's our file. Here's what it looks like. But that's obviously not a very useful format for us, right? Because having a whole line at a time, I mean, it helps us like spit out the file again if we wanted to just review the data. But you could also do that by just double-clicking the file, right? So that's, by itself, it's not super useful. So what we probably want to do is actually try to split up these lines, right? Because each of these lines contains 3 pieces of information: a line number, an accuracy or RT, and a line number, an accuracy, and an RT. And we want to actually recover these individual fields back, right? Because that's what's going to let us do some data processing. So what we probably want to do, let's just comment this out for right now and do something else instead. So what we probably want to do is read these back into some lists, right? So I'm going to call 1 trials, 1 accs for accuracies, and 1 RTs. I'm going to start off with an empty list. Hopefully, again, this is something that you guys have seen before. So we start off with an empty list, and we're going to add to each of these lists 1 line at a time. So one thing we can do, what we really want to do is we want to take these lines that have the actual data in them and split them apart by the tabs in them, right? So what we're going to do is we're still going to use a for loop, like the one we just had. Although I'm going to make one little change here. Instead of just doing x range of n lines, I'm going to do x range up to n lines, but starting with 1. And the reason is because I know because I created this file format that the first line actually contains headers, right? Like it contains the labels trial number, accuracy, RT. So if I'm reading back in my data, I actually want to ignore the first line of the file. So I actually don't want to start with line 0 as Python numbers. That I want to start with line 1, which is our first line of real data, right? But then I want to go through all the rest of the lines. So I'll start off saying the same thing I did before. Current line equals all lines, bracket line num, right? So again, now current line is a string with everything on that line, including the tabs in the new line. And what we can do is there's a little function or a little method of of the string object called split. So again, just to illustrate this for you guys, let's say I have a string, have a string called Bob. But Bob is just Bob, 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 Bob. And let's switch now and say dot, 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 or something like that, right? So that's our string name, Bob. So if I do bob.split, you see that this is a method of the string object. And if I want to split using the character O as the separator, it gives me this. So what this says is the split method takes in a character that you use to split your string into a list of things, right? So what this does is it splits up this string. You see that we've got B, 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 D, which is where I switched from B's to D's, D, 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 right? So what this does is splits apart the string into a list of shorter strings, taking out the separator and using that as the cue that we want to start a new object in the list. So a more realistic example might be, if you had space-separated data, like if I wanted to, list the staff members in psychology. So I'd have Matt, Lizzie, Peter, Ian, Kirsten, Neil, Jess, Mark, Truma, Rika. Is that 10? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I didn't want to leave anybody out. All right. So if I wanted to use that and make a list of, lecturers, I could say staff equals data.split and give it just a space, right? Because I've got spaces separating my elements. And then staff becomes this nice list of strings where each string is anything that happens up to a space. Then we take out the spaces and give the next thing that happens up to a space and so forth. Everybody see how that happens? All right, so this split function, you can imagine, is going to be very useful to you in processing your data, or the split method. So what we can do back in the code is say, all right, call it like, let's call it current cells or something like that. We're going to split this line up into cells of data. So that's going to equal current line.split. And this time, our data is not space separated or separated by O characters or something like that. It's separated by tabs, right? So again, you give it that \T, which is special code for tab. So it's going to split all the cells up by tabs. And then what we can do is, so what we're going to have is current cells is now going to be hopefully it's going to be a 3-item list where the first item's the trial number, second item's the accuracy, third item's the RT. And we can just say, so we can say like current trial equals current cells 0, right, which is the first item in current cells. Current accuracy equals current cells 1. Current RT equals current cells 2. Right? And then what you can do is if you want to pop each of these onto the list, you can say trials.append current trial accuracies.append current accuracy and RTs.append current RT. Now, again, this is just to sort of make it more clear that I wrote this all out. What I could have done is I didn't really need to create these temporary variables, current trial, current accuracy, current RT, right? Because I could just put this current cell 0 in for current trial, right? So I could just append cell 0 directly to the trials. But this is just to sort of explicitly label everything in case you're having trouble following. Okay, so what that should give us at the end, let's see if this works. Let's just print these out to see if it works. So print trial numbers, and then let's print our trials list, and then we'll print accuracies, and then we'll print our accuracies list, and let's print RTs, and print our RTs list, right? So that's just going to tell Python to print those all out so we can see what they are. And let's run this and see what happens. Okay, so now it just ran this, and it printed out trial numbers, 1, 2, 3, 4, 5, so that's good. Accuracies, 0, 1, 0, 0, 0. RTs, looks like it mostly worked. 1573, 1059, 1346, 873, 933. The only thing you notice is the RTs still have this new line character stuck onto them, right? Because it doesn't, we haven't told it yet to like get rid of, part of the line is the character at the end telling you to go to the next line. So we haven't yet told it to get rid of the character at the end of the line. So it treats that like part of the RT, right? But that's still pretty good, right? So it did effectively split up our data. Again, if we look at the actual raw text file here, to compare, right? So we have trial numbers are 1, 2, 3, 4, 5. Accuracies are 0, 1, 0, 0, 0. RTs are 1573, 1059, etc. Right? So that's all pretty good. Okay, so that's all right, but what we really want to do, like we said, is, well, at the very least, we want to get rid of those excess new lines, and we also want to do a couple other nice little things. So let's comment this out and revise this a little bit more. Actually, before I commented it out, I should have copied it because I'm going to use a lot of this. So let's introduce a couple other little improvements to this and see how we can refine our script. So, okay, so here's what we just had, right? So I'm going to do a couple things. One, just for the sake of introducing you guys to some new syntax, you don't have to use this, but you may actually find this a little more intuitive, and this will kind of get you prepared a little bit for Matlab. So I don't think we've explicitly done this ever, but let's look at a slightly different way of doing a for loop if we're dealing with something like this line number, which is a list of strings. So let's go back to our example here in the shell, right? So we have this variable staff. That still exists, right? So it's everyone on staff here in the department. Sorry if it's a little cut off at the bottom there. I think if I hit this again. There we go. Okay, so there's my command line at the bottom. So let's say I want to do a for loop where I want to print off every staff member on its own line or something like that. So I could say something like for staff num in x range of the length of staff, colon, print this staff member, colon, placeholder, dot format, and then whichever member of staff we're currently on, so staff, bracket staff num, right, refers to the current staff member. Right, so that just goes through the list and prints us each out on a line. But there's actually a slightly easier way to do this. If you want to loop through the items in a list, right? So we've got here a list with 10 items. And if you don't care about keeping track of the number of the item you're on, because right now what we're doing, right, is we're figuring out the length of this list, and then we're creating an X range or a range, right, that goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and assigning each of those numbers to the variable staff num every time we go through this for loop, right? So the first time through the for loop, staff number is 0, then it's 1, then it's 2, then it's 3, all the way up to 9. But what we can actually do is we can actually do for loops in a slightly different way. So we can loop through things that aren't numbers. And I think some of you have figured out a way to do this already on your problem set, but if you haven't seen this already, we'll do it now. So another way to do this is to say for staff member in, I'm totally giving you the answer to one of the problem set questions now. I'm going to have to get rid of that one. I just remembered I was going to have you figure this out for yourselves, but that's okay. For this staff member in staff, we can say print this staff member, colon, placeholder, dot format, staff member. So we can kind of shorten that a little bit or simplify that code a little bit. See how that is. Okay, so that does the exact same thing. So what this is doing, and this sort of hopefully makes sense to you as sort of English language syntax, is it's saying for every staff member in the list staff, so that hopefully that English language phrasing should make sense to you, right? So for each staff member, do this, right? So for each staff member, give them a raise. For each staff member, you know, bring them a snack. These are all things the staff members would like you to do. You know, that's something we would say in English. But what that means in Python is when we say for staff member in staff, what we're really saying is we're going to create a new variable named staff member, and it's going to loop through the items in the list staff. So for this to work, this has to be a list, right? So each time through the loop, staff members is going to take on the value of the next item in the staff list. Does that kind of make sense to everybody? Does that kind of make sense, hopefully? So that's just a slightly different thing you can do that's going to make things a little bit simpler. And anyway, what I just want to show you is that this is actually no different than what we were doing before, right? So back before we started using xrange, we were using like range, right? Which just creates a list, like range of 5 is 0, 1, 2, 3, 4. It's a slightly different idea, but it's actually, to Python, it's the same thing as when you say like for num in range 5. It's doing the exact same thing, right? Range 5 is creating a list of 0, 1, 2, 3, 4, and number each time through the list is taking on the value of the next item in the list, right? So actually that's exactly what we did before. It's just you probably aren't used to doing it with lists of strings instead of lists of numbers. Okay, hopefully that makes sense to everybody. If not, we can talk about it later. Okay, so one thing we could do to kind of condense our code a little bit is we could actually say for current line and so get rid of this x range because we don't really care about what number line we're on, right? We just really want to get each line in turn and do something with it. So what we can say is in all lines. Oh, so this is one tricky thing that we're going to have to do actually. So the only tricky thing is we don't want to actually loop through all of the lines, right? We only want to take lines from 1 onward. So there's, again, a special syntax that you guys can use. I think a couple of you might have stumbled on it already, but not the rest of you. So if we want to only take the lines from 1 onward, right? We don't want to take line 0. You can use this syntax that says 1 colon. I know it seems like a lot of colons in a small space, but that's how it works. So again, if we have our variable staff, right? So if we want to cut, if I'm fired, right, which could happen really at any moment. So if I get fired and we want to look at the staff, what the staff list would look like without me, you just say staff 1 colon. See what that does? So before we had the whole staff list, this only gives me the staff from 1. Basically, the colon means to the end by itself. So you could do something like, remember this is sort of like what you do with range and x range. So you could do something like, if we wanted just the first couple of members of staff, we could say staff 1 colon. Well, let's put me back on. So me, Lizzie, and Peter, for example, would be staff from 0 to 3. And again, remember, Python's sort of funny. The second number actually is sort of the end point, but not including that number, right? So it goes, staff from 0 to 3 goes 0, 1, 2. It's a bit weird that way, I know. You guys are going to love Matlab much more because the Matlab scheme for numbering items in a list makes much more sense. But staff from 0 to 3 gives me 3 staff members, 0, 1, and 2, right? So staff from, you know, like 4 to 7 would give me 0, 1, 2, 3, item 4, 5, and 6, stopping before 7, right? But if I want to just get the staff members from staff number 7 to the end of the list, that's just Mark Schumacher, right? Everybody get that? So what I can do is if I want to loop through all the lines in the file except for the first one, if I want to loop through all of them, it would be 0 colon, but that would just be the same as saying all lines. So, but 1 colon means everything from line 1 onward, okay? What that does is it lets us effectively just take out that line of code because current line is now going to represent each item of this list, all lines, which is a list of strings, each string being a line of code. Okay, so that's one thing we can do. So that saves us some code, but it doesn't improve the functionality any. But what we can do is add one more little line here. Basically what we want to do is we had everything working. We just didn't like that little new line guy on the end of the RTs. So ideally what we want to do is take out any new lines from our line of code before we do anything else, right? And you can do this with any character you like. So for example, well, let's go back to this before we go too far. So what was our our variable we called data earlier, right? Was Matt, Lizzie, Peter, Ian, Kirsten, Neil, Jess, Mark. So if we wanted to see what our, if we wanted to take a certain character out of that list, we could actually say data.strip. Let's say we wanted to see what all of our names would look like with the letter A taken out. It's a dumb example, I know. Whoops. Oh, sorry. I take that back. Well, it did work, but it worked a different way than I thought. Right. It'll only take off the characters you specify at the beginning or the end of the string. There's another function, I believe, for taking off characters elsewhere. But strip, what it did is it took the letter. Sorry, I was again thinking about Matlab. But it took off the A character, but it took it off at the end of Rika's name, right? So it didn't take it off from my name, it didn't take it off from Ian's name, and so on. But it does strip anything from the end of the string that you don't want, according to what character you say, right? Now, if I said data.strip p or something like that, it doesn't take anything off, right? Because it says basically if the string begins or ends with that character, take it off. So that's very useful if you have something like, if you read in some data that's separated by spaces or something like that. So if we say data equals space, 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 Matt, Lizzie, Peter, etc., space, 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 right? So that's our data now. And if we say data.strip, strip all the spaces from the beginning and the end, that just gets rid of all those extra spaces and, cleans it up so that we really only have the stuff we care about. Okay, so anyway, that's a long way of saying what we can do is we can say current line.strip, and if we only want to strip out that new line character at the end of the string, we can do that. And hopefully that should then sort of fix that little issue where the new lines were still showing up on our list of response times. Okay, so weirdly it changed the font again for no good reason, but the key, oh shoot, that did not work at all. Why didn't that work? Oh, should work. Doing something funky here. Well, it works in my other code. You just see something here. Alright, let's quit PsychoPy, see if it's just acting funny. This definitely works on the file I did before. Oh, I'm being a dummy. Alright, I'm being a dummy. It's okay. All is well. So I forgot one thing. So this is a little bit tricky because with functions like this, I was correct that this will strip out. Let's put the \n back. This will strip out new lines, but it doesn't change current line. So if you're telling current line strip out, let's again go back to our data example. Let's say data equals Matt, Lizzie, Peter, space, right? So here's our data string. And if we say data.strip spaces, it strips out the spaces. But if we look at what data actually is, it's still Matt, Lizzie, Peter, etc. Okay? So what data.strip does is it returns a value that is the stripped out data, but it doesn't actually change the underlying object, right? Does that make sense? So you have to be careful when you call a method of an object. And this is sort of a, I wouldn't call it a shortcoming exactly, but it's something that's tricky with objects. Is objects have the ability to modify themselves, but if you call a method of an object, it might just return a value instead of actually modifying the object, right? So it's often a little imprecise. If you say strip something from a string, do you mean change the string, or do you mean show me what the string would be without the spaces, right? And in this case, it means show me what you mean, but actually, in other cases, it might actually change the string. So that's one thing that's a little bit confusing about using objects is it could be either of those. So what we actually have to say is, say current line equals itself with the new line stripped out. That will actually change current line instead of just returning it. All right, so now this will work. So we run the file. Now we get these nice RTs with no new lines. Now there's only, I know we're at almost an hour here and we haven't done much except print out some numbers. But that's, that's pretty good, right? Because that gives us these lists that we could use to do some analysis. We could say, oh, what's the average RT for all correct trials or all the incorrect trials or whatever. You could easily write some code to do that, except for one problem with this output. There's still one problem with how we've read in this data that's going to potentially prohibit us from analyzing the numbers. Anybody know what that is? Okay, yeah, good. So what we've got here, they look like numbers to our eyes, but they're actually not lists of numbers to Python. They're lists of strings, right? Because we started with text. So if you read a file that's text in, it's always treated as a string, right? Because it's like it's text. Even if the characters in the text are numbers, it still says this is a string with some printed numbers in it. It's not representing it as the actual number, right? It's representing it as the text of that number. So what we really want is a way to convert, what we have done is we've taken out all the characters that aren't numeric, right, by stripping out the tabs and the new lines and stuff. But what we want to do is actually say, no, we want the numeric value, not just the string representation of the numeric value. So it's very easy to do this. And actually, this is something that we did. Shoot, I keep commenting and then copying. This is something that we did a form of last time, although we did it pretty quickly. So if you want to tell someone, if you want to tell Python rather, not a person, if you want to tell Python to interpret a string as a number, or to interpret anything as anything else, it's pretty simple. So if you have a string like my num equals 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 5, if you just ask it what my num is, it just gives you that string. But if you say int my num, it gives you the value as an integer, right? Now if you have my num equals Bob, and you try to do an int of my num, it's not going to like that, right? Because Bob isn't an integer, Bob is a person. But as long as the string is something that it can reasonably interpret as an integer, you can do that, right? Now similarly, if you said my num equals 1, 2, 3, 4, 5, and you wanted that to be interpreted as a decimal value, you could say float. Remember, we called decimal values floating point numbers. Float my num does the same thing. It interprets it as a number, but now it interprets it as a decimal number, a floating point number, right? So this is the formal term for this in computer science is typecasting. It doesn't mean typecasting like for actors, but what it means is you change the type of an object to another object, right? So in this case, we're changing strings to integers or floating point numbers, but you can also do the same thing. Like you could say, what is the float version of the number 1, right? And that tells us it's 1.0. Remember we said 1.0 in Python is a different thing than 1. 1 is a floating point value, 1's an integer. Now before, what we did if we wanted to change 5 to a floating point number, we would just do something like multiply it by 1.0, which is still a fine way to do it. But another way to do it is just to say float of 5, right? And similarly, if you wanted to see what the integer portion of something like 5.2 is, you can do that. Now, if I put an int of 5.6, what's going to happen? Anybody know? It's going to be just 5, right? Because the way Python interprets this is not to round the integer, it just lops off anything that isn't the integer part of the number. So it just ignores this 0.6 entirely and just gives you the integer part, which again may be something you want or maybe not. Okay, so anyway, again, all of that's a lot of explanation, but what it says is all we really have to do is at some point in here just change these values to be from strings to being integers. So for example, right here you could say current trial equals int current trial. So that's taking current trial, which was a string, saying what's the integer version of that, and setting current trial to be equal to this new integer value, right? So we're changing current trial from a string to an integer. And we'll do the same with current accuracy. And we'll do the same with current RT. All right, and if we run that, go to the output. All right, so now what we've got is what we wanted all along, right? A list of actual numbers, 1, 2, 3, 4, 5, actual numbers 0, 1, 0, 0, 0, actual RTs, these things, right? And from at this point, this is sort of the realization, or all you need to really be able to do with any sort of regularly formatted data if you want to read it in and do stuff with it, right? So if it's tab separated or comma separated or something like that, as long as it's a text file, it's pretty easy to read it in and convert it to lists of numbers. And now you can do anything, right? So if you wanted to average your RTs, you could just say something like print average RT, and then you'd print out sum of RTs divided by length of RTs, right? That's just the sum of them over there, the number of them. And oh look, average RT is 1156, right? So your analysis, once you've got the file read in, you can do all kinds of stuff, right? Your analysis gets pretty simple. And of course, if you had very complex data with lots of different, if you had conditions thrown in there, or if you had, multiple responses per trial or something like that, you might have to write more code, more loops and stuff to process the data. But once you've got it in, you can do anything with it that you could do with any numeric data. Okay, so any questions about that? That's sort of the end of the reading files demo. Does that kind of make sense to everybody? Everybody cool with reading files so far? All right, if you want to take a little break. So we'll take a break and then we'll come back and talk about just a few other random topics.
Oh, hello there. I'm Matt Johnson. You may know me from such video podcasts as C83PFP, Programming for Psychologists. I was just sitting here by my virtual fireplace, contemplating the wonder and beauty of computer programming when you happened along my way. But I'm here today to tell you about a much more serious matter. It seems that a horrible accident has befallen the video from the second half of today's podcast. An unfortunate combination of sleep deprivation and a poorly designed user interface has unfortunately resulted in the later parts of the lecture not being recorded. I sincerely regret this error, and I will shortly be retreating into my self-flagellation chamber to repent for this mistake. But I hope that you will be able to mostly recreate what we talked about from the online lecture slides with a little bit of additional guidance. Over the next couple of minutes, I'll give a quick recap of what we talked about in the second half of the lecture today. I hope that this will help your understanding, but if you have any additional questions, feel free to contact me for a private appointment. Again, I regret the error, and I hope it has not caused you undue turmoil during this hectic time of year. My best of wishes to you and yours during this holiday season, and I wish you a very happy new year, full of exciting programming adventures.
Okay, so here we go again. This is just a quick recap of what we talked about in the missing episode, only much faster and probably much less hilarious and charming. So here we go. We just talked a little bit about things you could do to practice over the break, because there are no assignments over the break. For those of you in the live class, I'm going to be really gone to the USA between, I can't see my mouse pointer, between December 15th and the 7th of January, and then I'm gone again from the 29th of January through February 13th, 2013. So we're not having an actual class again, or a podcast for that matter, until the 19th of February. So that's actually a couple of months from now. But that doesn't mean people should let their skills lapse over that time. So I'm hoping people will take the holiday time to review what they learned over the semester. If you're one of the folks who's doing pretty well, understanding everything, basically what I would hope is that you could work on your final project during this time, hone your skills, do some extra enrichment and that kind of thing. And of course, keep in mind, like I said, that we're going to be doing Matlab in semester 2, but that doesn't mean we're going to be abandoning Python, right? So the final exam is cumulative, meaning there's plenty of Python on it. And a lot of the time when we talk about Matlab, we'll be talking about Python also. So the better you understand Python, the easier semester 2 will go for you with the Matlab stuff. Now, in terms of what you might want to study or look at over the holidays, if you're having some trouble, you might want to look again at the lecture podcasts like this one, lecture slides, and again, if I'm going quick through these, remember that the PDFs of the lecture slides are always online in the class Google Drive. Take a look back through old problem sets and the keys to the problem sets, because really the problem sets are a good indicator for you what's going to be on the exam, what kinds of questions might come up in future problem sets, and the keys are good indicators of the kinds of answers I'm looking for, at least ideally. So even if you think you understand everything from the old problem sets, it's still probably worth going back to them and just making sure you'd be able to answer everything on them. Because nobody has scored a perfect score on any problem set yet, so there's always things you can do to improve. If you don't understand the material on older problem sets, that would be a good place to start if you're going to be brushing up or studying over the break. Other resources to talk about, we've talked about Learn Python the Hard Way plenty, but I do recommend that, even though it doesn't have anything to do with psychology or PsychoPy, but it will teach you a lot about the core foundations of the Python language and programming in general, and so because of that, it'll make the PsychoPy experience much easier if you understand the language really well. And again, it covers some things that we don't cover in class, but it doesn't ever hurt to learn more as long as you don't get confused. Stack Exchange and Stack Overflow are good websites for specific questions, so if you find yourself wanting to know how to accomplish a certain task in Python, when you Google it, probably you'll come up with a link to Stack Exchange or Stack Overflow where people answer questions about programming. You can also ask your own questions, but I think probably at the beginner level, most things you would think to ask will have been asked before if it's about Python the language. That's not a good place to go for PsychoPy questions in particular. But if it's about how to do something in Python or Matlab, those are good places. The official Python documentation's also good. Oh, here's my mouse. There we go. All right. So the official Python documentation's also good. It's a little drier than Stack Exchange. On Stack Exchange, they'll try to explain things a little bit better and in a tone that is more appropriate for the learning level of the person asking the question. The official Python documentation is a good place to go when you kind of know what you're looking for and you just need details on how a certain function works. So we were talking earlier today about like a Python function to tell you what the current date and time is, right? So you might Google Python current date time and come up with a Stack Exchange or Stack Overflow page that tells you to import the date-time module. But then to figure out how the date-time module actually works, you'd probably want to look on the official Python documentation. And then if you have PsychoPy questions, you can go on the PsychoPy website. Remember, we said there are the two types of documentation for PsychoPy, this one here and this one. Sometimes they're updated at different times, so one of them might be more up to date than the other. It just depends. This one tends to be a little bit more written in human language, and this one tends to be a little bit more just pure documentation, the same way that the official Python documentation is. So this one's a little bit more user-friendly, but sometimes this one might be more complete or up to date. And one thing that's not on the slide here that I mentioned in class was, PsychoPy also has a mailing list, like a Google Groups email list, and it wouldn't be a bad idea to get yourself on that email list. If you have a tricky problem to solve, I mean, you could ask the PsychoPy mailing list, but it probably makes more sense to ask me first, because I'm on the mailing list, and I'll see if you email the mailing list trying to get too many answers to your homework. But it's a good place to sort of see what other people are asking about PsychoPy. Most of it's about the builder, but there still are questions about the coder. And it's a good place, good to just kind of read over it every day. If you subscribe, you'll get a daily digest email. And, you'll see kind of what kinds of things people are asking, bugs that people find, and get a sense of, what people are able to do with PsychoPy and, sort of test your level of knowledge against theirs. You can also get books from the library if you really want to. I don't know any particularly great ones, but that's always an option. There are lots of Python books in the campus library. And if you need any more resources, here are some more. There's an online Python course at Code Academy. I have not taken it, but I do know it exists and it's free, so that might be worth looking at. This blog is not directly relevant to the class, but again, it's a good sort of resource for just reading about computing in psychology and cognitive neuroscience, and it's written in a nice style by someone who has experience with a lot of programming and hardware work in all kinds of different applications in psychology and cognitive neuroscience. So it's an interesting read to keep up with. And there are plenty of social networks and social news sites and online communities like Reddit that have subgroups for programming or learning programming or Python, for example, in the Reddit case. And of course, there are plenty of other websites as well. So if you're a Redditor or thinking of becoming one, these are good subreddits to subscribe to and, check out the headlines and see what people are saying on these communities as well. And again, it's a good place to ask for advice, although probably your classmates and I should be your first line for getting advice in this class. Okay, one more site for the people that want a real challenge. We talked about Project Euler, which I won't go over the full description again, but basically you can sign up for a free account. You just sign up with a username and password, and it's a series of increasingly difficult programming problems that you can solve with any programming language, but Python's actually one that's particularly well suited, so I would suggest trying these with Python. And basically the idea is they're all mathematical problems that you have to solve with a computer, so they involve larger numbers than you could compute by hand. Every problem has an integer solution that's usually kind of a big integer. So you need a computer to do the problem, but the whole point is if you do it cleverly, it shouldn't take the computer days and days to compute the answer. It should take the computer less than a minute or so to compute it. So the first few are pretty easy. They quickly get pretty difficult, actually, even for experienced programmers. But the first 30 or 40 may be within your range of expertise, depending on how skillful you are right now and how much skill you develop over the rest of this year. So if you're already doing pretty well in the class and want a challenge to kind of see how clever you are at coming up with algorithms for calculating certain things quickly, I recommend Project Euler. And again, it's not actually about psychology, but it will just help your general programming skills. Okay, so the last thing we did here, and I won't go through this whole demo again, but this was a quick demo we did talking about reading code and running it by hand as if you were the computer or the Python compiler, the Python interpreter, actually. So, like I said, I'm asking you to do some of this in problem set 06. So we are going to practice this a little bit. We already did this in class, but if you weren't in class or want a review, we'll do it just quickly again. And the idea here is, I think I said earlier that one way a lot of people go about programming when they don't really know what they're doing or they're pretty inexperienced is, you might kind of have a rough idea of how something's supposed to work, and then you really do a lot of tweaking and guessing and playing around trying to get something to work without really knowing exactly why it works if it eventually does work. And that's okay to do a little bit, but it doesn't really help you understand why your code works when it actually does. So a better idea is to really understand your code or someone else's code. And one way to do that is by really going step by step through a program and trying to figure out what's going on in every single line of the program. So what I suggest doing is literally doing this on paper, getting a sheet of paper, writing down all the variables that get created in the course of an experiment, going line by line through the experiment. Sorry, not an experiment, a program. It's a little late here. And like recording on paper what's going on in the experiment. So this is a function that I threw out of the problem set right here, because it was getting too long. But what I was going to do is ask you to really trace through what was going on in this program if we were trying to get the prime factors of a number like 5,460. So again, this is something that you maybe haven't quite seen before, but here we've got a function definition right here, right? And usually what we do is put our function definitions in one file and then import it from another file. But what you can also do is have all your function definitions and then have your Python code that actually runs below them. And you can see that here the first thing and only thing this code does is call the prime factors function that's defined up here. So just for the sake of getting it all in one file, that's what I did here. So there's only one line of regular code that's not part of a function definition to print the prime factors of 5,460. So what that's going to do is, of course, run the function prime factors for the integer 5,460. And what I'm wanting you guys to do is to just go through every line of this code as the Python interpreter would go through it line by line and do all the checks and while loops and ifs and elses and so forth, and actually see if you can get the same result that the computer delivers, right? So if we run this, we see that the prime factors of 5,460 are indeed 2, 3, 5, 7, and 13. That is a correct answer. And so basically what you would do if you were tracing this out by hand is, you'd say, all right, well, here's the line of code that we're going to try to execute prime factors of 5,460. So then the first thing that's going to happen is we're going to be on this line of code. So what's going to happen is the variable sum integer, right, which is the argument to the function, but it's also just a variable that you can refer to within the function, is going to have this value, right? Hopefully that came into focus. I guess we'll find out. All right, so that's that line of code. So what's going to happen on this line of code? Well, we create a new variable called factor list, and we set it equal to be an empty list, which I'm just going to represent the same way on paper that we do in Python with empty brackets, right? And we're going to create another couple of variables here and here in these lines. That's pretty straightforward. So we're going to create last factor and set that equal to 0, and cur check, which is equal to 2. Right, so hopefully that shows up. Okay, so here's where we start getting into actually the tricky part of the code, right? So now we want to say we have a while loop. And remember how while loops work is if this condition is true, we execute all the code inside the while loop, right? Oops. All the code inside the while loop like this. And whenever this condition, and then after we're done executing, we go back up here to this line, check to see if the condition's true, run through the loop again if we need to, and so forth, until this condition turns out to be false, in which case we go to the line after the while loop, which is here, and in this case we can see that that's going to end the function because it's going to return the variable factor list. So we know that we have this while loop that we're going to go through over and over again until we have all these prime factors in factor list. So what's this test here? So we're testing to see if current check, I say current check because that's what cur stands for, is less than or equal to some integer. Well, according to this, cur check is 2 and some integer is 5,460. So this is less than this. So that's true. So we're going to go into the while loop. And the first thing we have after the while loop is an if statement, right? So similar kind of idea. So if this statement is true, we're going to do this stuff. Otherwise, because we have an else in here, we're going to skip down to this line and do this, right? So if
some integer modulo cur check. So that means the remainder of some integer divided by cur check is equal to 0. So let's see, what is some integer divided by cur check? Well, I'm just going to go up here and check that out real quick. So some integer is 5460, divide that by 2, and we see that comes out to 2,730. I'm just going to make a note of that number. Which is there's no decimal part to that, right? So the remainder of that division is in fact 0, which means this condition here is true, and we do want to do this code, right? Now we want to know if last factor is equal to current check. Well, one's 0 and the other is 2, so the equality test here is false, and if we say not that, it's true, right? So in fact, last factor is not equal to current check, so that means we will do these lines inside the if statement, which is to append the current value of cur check, which is 2, to the factor list. So now what we're going to have is a factor list with just the number 2 in it. So you see I crossed out the old empty list, put in a list with just the number 2, then the next line of code we're going to execute is say last factor equals current check, so we're going to cross out the old value of last factor and substitute the value of current check, right? Okay, so that line of code is executed, so now we go to the next line of code, which gets us outside the previous if statement, or gets us out of this if statement, but we're still in this block for the first if statement. So the next thing to do is to also change the value of some integer and make that some integer divided by current check. So we said that was 2730. So now we're going to have a new value of some integer, right? Okay, I just realized that this is going to be very small, so maybe I'll make the cut-in box a little bit bigger so that you can actually see my piece of paper here. Okay, so we've executed this line of code. That's everything within our if here, right? So because we did this stuff, we're not going to do what's in here for the else. So we're going to skip over the else, which means we're at the end of our while loop, right? So that means it's time to go back to the beginning of our while loop and check this condition again and see if it's still true. So is cur check less than or equal some integer? Well, yes it is, because 2 is less than 2,730. So we do this line of code. Is some integer modulo cur check equal to 0? Well, let's see. So we want to see if the remainder of 2730 divided by 2 is 0, and it is, right, because it comes out even, so it has no remainder. So we go in and do what's in that if statement, which is here. Now, does last factor equal current check? Well, actually it does, right? So, because we just set, previously we said last factor equal to current check, so this equality test comes out true, but then if we take the not of that, that means it's false, which actually means that this full condition here is false, and so we don't do what's in the if this time, right? So we skip over these two lines, we don't do those, and we go right here to the next statement after the if, right? So we say, all right, now some integer is going to be itself divided by cur check, so that's that 1365 that we just figured out, right? Because that's 2730 divided by 2. So there we've updated our value here, hopefully. And once again, we don't do the else, right? Because we were doing what was inside the if, which means we're back to the beginning of the while loop. Doing the test again, is cur check less than some integer? Well, yes it is. 2 is still less than 1365. Now here's an interesting case. Now we do the if statement again, right? So we want to see if the remainder of some integer and cur check is equal to 0. Well, that's going to be 1365 divided by 2, which has a remainder, right? It has a decimal point. So the remainder is not equal to 0, which means we don't go down and do the stuff under the if statement. Instead, we do what's under the else statement, right? Because else handles every other case if the thing under the if statement is not true. So we go down here and say, all right, this means that what we do is we update cur check to be its previous value plus 1, right? So it goes from 2 to 3. Okay, well that's good. So hopefully you can see what we're doing here if we keep going. What we've basically done here is we've, we started out with 5,460,
in the value some integer, right? And we went through this cur check is basically a value that we're checking to see if it's a factor of that number. And what we've gone through is, we've checked 2 to see if it's a factor of that number, and it is. So we've added that to our factor list, right? And then every time we find a factor of the number we're checking, we divide it out of that number, right? So we first divided 5460 by 2, and then it was still divisible by 2, so we divided that again. And what's going to happen basically is we're going to go through here and find that it is divisible. Let's see, 1365 is divisible by 3, right, as we found. So what's going to eventually happen is we're going to append a 3 to the factor list. Then we're going to check to see if any more 3's can be divided out, and they can't. So we're going to increase the number we're checking to 4. We won't be able to divide the integer we're checking by 4. So this will increase again to 5. We will be able to divide out a 5, so we'll add that to our factor list, and so on and so forth. So if that doesn't make sense, I encourage you to go back through and kind of run through the code again, going on from the point where I just stopped here, and just see how that gradually builds up this list that you see down here, which is what should eventually get returned by the function. Okay, so that's the idea here, is that if now it's a little painstaking and slow, but the more you do it, the faster you get, obviously. And I think it is a really good way to kind of step through a function and see what's going on, right? Because probably when we first pulled this up, this was just kind of a random mass of code. The variables and the structure of the code didn't make much sense, but hopefully as we stepped through, you started recognizing some patterns, kind of seeing what it looked like all the variables were doing, and so forth. So that's the idea here. And anyway, what I was just going to show you is that, and what we did see in class today, is that this is one of the Project Euler problems, is to find the largest prime factor of this extremely large number. And PsychoPy has changed the font on us randomly again, but we've got our answer here, actually. So 6,857 is the proper answer. And you see that happened. This isn't actually a particularly efficient algorithm for getting prime factors of a number, but clearly it was quick enough. So, so that's good. So that's actually an answer to your first Project Euler problem. So if you understand that, I think that counts enough for you to call it solved, and go on Project Euler's website and claim that solution as your own. So if that doesn't make a whole lot of sense, you can step through the function again, and hopefully you execute enough code by hand and it will start to make more sense to you. Okay, so as I said, there is some of this on problem set 6. Hopefully that makes sense to you. Hopefully you'll do well at tracing out code by hand, and that will generally help you when you need to do the same thing to debug your software, right? When you say, well, I don't understand why my code's doing this, one thing I might say to you is, well, start with a piece of paper, trace out what all your variables are going to be, and step through it until you find where the code doesn't do what you thought it was supposed to do, right? And at that point, you know that there's something wrong, and hopefully, by stepping through, you see what the wrong step is that you took, and you can then fix it somehow. Okay, so that's a super quick recap of what we talked about in class. Hopefully that works for you guys. Hopefully that replaces the 40 minutes or so missing video, which was just basically that, but a little bit slower and longer. So again, have a good break. Hope everybody enjoys problem set 6, and I will see you podcasters and live humans alike once again in February for the beginning of the Matlab half of the class. All right, see you then.